All right. Okay, so today we're going to talk about simulating energy uh, costs for for a model in which we are simulating power usage. And the challenge with this is when you have changing prices through time, you have to set up logic in your model that accounts for those changes and sets the correct unit price depending on those times. And it you can use in GoldSim, you can use the run properties to calculate these changing rates. So there are some tricks to it because you have to set up some events and switches to allow for these changes. So we'll walk through that. But what I'm going to do is start with a model that is found in our library that calculates power usage. Now I'm just using one that's from our library. You could apply this to any model that's simulating power usage. So what I'll do then is go to our website and then what I'm going to do is download the model file that we want to use. Stand by 1 second while let's see here. Okay, so on our website, you can see that at the top of the screen, there's a link to our library, and then you click on Model Library. Then I'm going into Applications, and from within the applications, there's a section called Hydraulics, and then down at the bottom, there's a pumping head problem. So I will go ahead and grab that one, download that, and I'll go ahead and open that. Okay, so here it is. Close this one here. Okay, so just to review, if you haven't seen this model before, if I run this model, then what you see is a pumping plot. So in this model, you don't have to know all the details, but essentially there's some changing water levels, and depending on the water level, the pump will pump at a different rate. As the water level increases, the pump it's harder to pump against higher levels, so the flow rate goes down. There's also more energy required to pump water against a higher head there. So we can calculate the power usage of this pump, which is done in this container here called Power Calcs. And when I go in there, you'll see that there's this actually shows the efficiency versus the cost, but we could also just plot the power usage here, and so that's showing the power usage through time. When the pump is turned off, obviously there's no power being used, and the resulting energy, and this is actually mislabeled, which is something we'll talk about, but this is not the power, this is the energy. When I plot that, you'll see it's only accumulating during the times that the power is being used. Okay, so this model, there's a lot going on here to calculate how much power is being used, but we won't really focus on that. In this model, we're just going to be looking at the power itself that's being used for this model. Okay, so I'm going to go into this container called Power Calcs, and this is where we will spend our time. But what I want to do is review the pricing structure. So we're going back into the Excel file here, and this is the rate schedule here, and it shows that in the summer months we have this schedule, and then in the winter we have a different schedule. And there are two types of pricing for the demands, or for the energy usage. There's the demand and energy, and the demand is on a kilowatt basis. And so what this does is it looks at your peak demands during certain times. And notice that it says dollars per kilowatt. And so let's just review power versus energy. So the power unit, kilowatts, that's kind of like the flow of energy, and kilowatt hours is energy, and that's the accumulation through time of the power. And so the demand would be looking at what is the peak rate at which you're using the power. So for example, max peak. So max peak at the time in which we are in a max peak period, we want to look at what was the maximum usage rate during that time, and then apply that cost for that period. And then the energy is a little bit different. So this is looking at accumulation of power through time. So it would just be applying this constant rate of 16 cents per kilowatt hour that's used over time. So it's it's a cumulative amount that's charged through time. Okay, so that's the difference between these two. And then what you do is you add these demand charges are discrete charges. And by the way, all of this rate schedule came from a real case in California, in which the prices and names have been changed a little bit here. But so this is a real situation. Okay, so we want to look at how we define these different periods, and those are defined down below, down here. And so for the summer, which is defined as May 1 through October 1, and that probably should be spelled out a little bit better here. That's midnight on May 1 to midnight on October 1. And so winter, I think this should probably be spelled out a little bit better too. October 1 through May 1, like that. Okay. So the peak hour is Monday through Friday, 12 to 6 p.m. And partial peak is 8:30 a.m. to 12, and then again at in the evening, 6 to 9:30, and then off peak is through the night and also on the weekends. It says there. And winter, it's similar, except there is no peak hour, and the partial peak is 8:30 a.m. All the way until 9:30 p.m. Monday through Friday, and off peak is in the night and on the weekends. Okay. And somebody said summer should be all the way to October 30th. You're probably right. I probably should say November 1 right here. That's a good point. Thank you. Okay. And by the way, this is midnight, November 1, right? So it doesn't enter November. It cuts off right at the beginning of November. So it really is through October 31st. Okay. So with that, now we can set up some logic in our model that captures what periods we're in. So that before we even talk about prices, we should set up some logic that says, okay, well, what period are we in? And so what I'd like to do is have a little selector element in GoldSim that through time will change between a 1, well, actually between 0, 1, and 2, where 0 is off-peak, and 1 is partial, and 2 is peak. Okay, so let's go ahead with that. I'm just going to save this real quick here. Desktop, that's fine. Okay, so going back to our model here, and since we're talking about half hours, 8:30 and so forth, I'm going to set up the model to have half-hour time steps, just so we can see those times happen. Otherwise, we don't want to set up triggers. We'd probably, if we had just an hourly time step, then our triggers would need, of course, to trigger on the hour. Or you could insert unscheduled events at the half hour at certain times, but have your basic step be 1 hour. Usually, GoldSim will still insert an event. You could have it force an event right at the half hour at certain times. But we'll just go ahead and put in a basic step of a half hour. I'm going to change this model to calendar, and we'll start in 10/1/2014, and then we'll go to 10/1/2015. So it's 365 days. And for now, I just want to do some testing. So I'm just going to run this for a week. Okay, then I'm coming down here to my basic step, and I'm going to change this to minutes, and I'll say every 30 minutes is our basic step. And I won't have any reporting periods yet, and we'll just save results on our basic steps. You'll see down here at the bottom, the advanced button has a little check mark here, meaning that something is not default in there. I'll go in here, and usually what causes this to not be default is the time to use for edit mode updates is not synced with the start time, and that's just because of the way that this model was originally set up. So I'm just gonna set that up so that it matches. All right, so everything's default there. Now keep in mind in the advanced here, there are times, I mentioned that maybe you want to insert an event on the half hour, even though you don't have half hour time steps. To see those events happen, you'd want to check this box here to include unscheduled updates. So that's one thing you need to get used to with GoldSim, where it differs from a spreadsheet, right? Is that we could have unscheduled events occurring in the model that are occurring at times other than our basic step. Okay, and the only way in this particular model where we could have unscheduled events up until now would be if our reservoir, if we hit an upper bound or lower bound in our reservoir, which may happen, and when that does, GoldSim will insert an event. Okay, the first thing I want to do is get our nomenclature correct here. So I'm going to change the HP to power, and this power calculation is it's a pump equation, and it looks like I'm already using the word power. Oh, I am down below. I'll have to change that. But essentially what we do is we look at the flow rate, we multiply that by oh, I'm sorry, the head. The first one is the head. This is the total dynamic head. That's the water level that it's pumping against, and multiply that by the flow, and then the unit weight of water, divide that by the efficiency, pump efficiency. Okay, so with all of that being done, we calculate the power, and then from here we can calculate the energy. So this is in horsepower. You could also translate this to kilowatts or megawatts or whatever you want there. And note that GoldSim is happy to report these however you wish. So we can change that to kilowatts if we want. It doesn't change anything, just the way that the results are displayed, of course. And energy, we have it shown in megawatt hours. Okay, this plot is showing pump cost. Okay, all right. So I have a very simple expression here called pump cost, which is just applying a constant rate of 8 cents a kilowatt hour. That's not what we want anymore. I'm going to delete that. Now what I want to do is create my own energy costs container. All right, now I'll go in here, and so now we have a blank screen, and now it is time to set up our logic. The first thing I want to do is determine whether or not it's winter, and I'm just going to use a status element to tell me true or false. It'll be true if it's winter, false if it's summer. Okay, so let's just set that up. Status elements are in the events category. We'll go here. And now, it's always good when you're working with Booleans, which is what this is, the result of a status element is a Boolean. It's true or false. And in cases like that, you want to name the expression something that gives it the idea that it's something that could be true or false. And what I'll do here is I'll say it is underscore winter. So if this is true, then it is winter. And then I'm going to trigger this to be true when something becomes true, and in our case, when the month. Now, I'm going to use a run property in GoldSim here. If you go to insert link here, you'll see that, oh yeah, we don't show them in this, but let me cancel this for a second and open up our browser. And in the model browser, you can right-click and select Show Element Subitems, and then you'll see our local properties container opens up. These are all run properties in GoldSim. And if you go to the calendar time folder, you'll see there's this this item here called month. Okay, and month is a counter. It doesn't have any units associated with it. All it does is count 1 through 12 as we walk through the calendar during the simulation. If I write an expression here and just say month, like that, and run the model, oh yeah, I don't have that set up yet. Currently, it'll tell us it's October, 10 for October. So notice again, it doesn't have any units, so it's just a counter, an integer counter. So I'm going in here to the set to true, and I'll say when the month is greater than or equal to 10, right? And as soon as it becomes October, it triggers it to be winter. We also want it to we also want it to trigger true when the month is less than April, or when it's prior to the end of April. So I'm going to say in here, it could also be, like for example, if it's January, if the number is 1, then we want to have a count there too. So I'll say when the month is less than May. Okay, so that would cover October through April. All right, and then the same thing on the other end. We could actually copy this exact expression, condition, and on the false side, rather than say on true, we could just say on false, like that. Okay. And so when we run this, it should evaluate to true, and it is for the duration, obviously, because we've only run it for 1 week. Okay, so that's our is winter. Something else you can do in GoldSim, and this might seem redundant to you, but you could also put a not expression in here. And while right now it seems very redundant and not unnecessary, it could be useful later on when you're writing a lot of logic like we are, where you just need something to read easily in your expressions. So all the not does is it just takes a Boolean and it outputs the opposite. Okay, so I'm going to say is summer, right, which would always be the opposite of is winter, and so these two things will always be opposites. It'll just make it so that when I'm writing my logic, I can read it. Instead of another way to do this, if you wanted to, let's say we have an expression here, and I just set my expression up to be a condition, a Boolean. I could go in here and say is winter. I could also say not is winter, and that would evaluate to the opposite. I could also say explanation point is winter, and that's always the opposite, like that. Okay, but as you can see, writing something like this is a little bit confusing because it's kind of hard to see the exclamation point, and also the not is winter, is just, not as easy to read. So I like having both of those in there. Okay, the next thing we want to do is we have to separate out our weekends. So I'm going to set up another status element that's called isWeekend. Is it the weekend is the question, right? Okay, so I'll do the same thing on true, and instead of referring to the month, I want this to look at the day of the week. As you can see over here in our browser window, there's a run property called day of week. Okay, and all that does is another counter, but it starts on, this one actually depends on your simulation settings, because some people like to have the week start on Monday and some people like to have it start on Sunday. And so if you go to our simulation settings, advanced, you'll see first day of model week, it says Sunday right here. Okay, so something to keep in mind. All right, so in our case, that's Sunday. So we want our logic to be day of week when the day of week is Sunday, or when the day of week is Saturday, then this is true. Notice I'm using two equal signs. You don't have to do that in GoldSim, but I like to do it because for most programming languages, that indicates not an assignment, but rather a condition statement. Okay, and same thing here with the on false. I'm just going to grab this whole thing, copy it, and go in here to the on false, and it's already set to on false. Put that in there. Okay, so to this one, we should see it change through time. And sure enough, we do. We see that October 1, we'd have to look at a calendar to make sure this is, well, I guess we could do that. Let's see, October 2014. We were starting on October 1st, so we started on a Wednesday, and the 4th was a Saturday. So you can see that the 4th and the 5th are showing up as a weekend there. So that's good. That's what we want. And now we can put in our not expression here. And we'll say, is it a weekday? Like that. Okay. So now there are two things we want to do next. We want to create events that trigger our off-peak period. And let's go back and review our off-peak period. So it says here that let's go to winter first. It says in the winter we have when it's essentially the night hours, or when it's a weekend. Okay, so we're going to want to set up something here that says, okay, first of all, if it's winter, and also if we meet these conditions right here, then it's off peak. Okay, so let's set up some logic that will give us that. And this is 21. Okay, so that's 9:30 p.m. until 8:30 a.m. and then the weekend and the winter. Okay, so what I'll do is let's just set up an event. I'm going to start there with an event, and we'll see how that goes. Maybe we can change this later, but this is an event that just triggers every time something happens, something that we tell it to trigger on, and we'll do it with a condition. So I'll say on true, and is it a weekend? And I'll say, yep, is weekend. Also, I'm going to go look back at this again and look at summer. Summer also says that weekends are off-peak. So regardless of the season, is weekend will always trigger a off-peak. Okay, so that's one way to trigger it. Another thing that will trigger it is that in the winter it's 9:30 p.m. on a weekday. So we'll go ahead and try that now. I'll do another true on true, and we will say then the hour, and there's another run property. It's called hour, and it counts 1 through 24, the hour of the day. So when the hour is equal to 21, so 9, and also when the minute, so this is, the minute is keeping track of the current minute of the simulation, and it resets every 60. Okay, so when the minute is equal to 30, and we could do either way. We could say that when the minute is equal to or greater than 30, that should actually be the same. We could do the same thing, I suppose, with the hour. We can test that. But both, and notice this checkbox down here. It says for simultaneous events, act only once. So there could be times, obviously, during the weekend when both of these are happening, both of these are triggering, and that's okay. GoldSim will just say, oh, I'm just going to use one of those, and that's fine. The point is that either one of these could be true, and that would trigger the beginning of our off-peak period. If we go back to our spreadsheet, this says that in the summer it's also starting the same. So it doesn't matter if it's summer or winter for the off-peak. Okay, now what I'll say up here is for this trigger, I'll say begin off-peak. Okay, let's run this model. And now what I can do, you can't plot the history of events in GoldSim, but you can plot the cumulative emitted events that occurred during the simulation, and that's what I'm going to do here. So I plot this. This shows us the number of times that this thing fired, and it shows us here that it fired toward the end of each day and the beginning of the, well, let's see, so this is, let's look when this fired. So this is in the evening, so this is the 9:30. 9:30. They did it again, but see, now we have a double. We have one that happened right after. This is for the weekend there. Okay, so that seems to be working, right? And somebody asked, shouldn't it be greater than 9:30 p.m.? Let me see. Greater than 9:30. Yeah, I think that's what I'm doing here, right? Because 21 is 9, and it also has to be the minute 30. Yeah. Oh, probably because you're looking at the chart and you're wondering. Okay. Yeah. Let's run the model again and just make sure. We can also look at a tabular view of this. So let's do that. Okay. So we'll go down, and it fired right here, and you can see it fired right at 21:30. So yeah, 9:30 is the time. And somebody asked, well, isn't it 9:30 to 8 a.m.? Well, I haven't turned it off. I haven't set up the off logic. This is the begin. Sorry, I haven't set up the end, right? This is just the beginning of the off period. I still have more to do here, so bear with me for a couple more minutes. Okay, so this triggers the beginning of the off peak. Okay, so now we need to create another one here that triggers the end of the off peak. Okay, so the off peak is triggered, as you have noted so far, that it's 8:30. Sorry, I keep forgetting. Yeah, 8:30 in the morning. So I will call this end of the off peak. Oops, no. End of off peak. And in this case, we don't want to end it on the weekend. We want to end it when the weekend or the weekday starts. So I'll go here and I'll say, is it a weekday? And as soon as that becomes true, that will trigger the end as soon as it becomes a weekday. Okay. Also, we want it to be whenever it's the weekend and also when it's 8:30 in the morning. But see, in this case, it's a little bit different. We don't want it to trigger at 8:30 in the morning on the weekend. Okay, only on the weekday. So I'm going to remove this one and go up here and say it has to be a weekday and this logic, which I'm going to change here in a bit. The hour is 8 and the minute is 30. Okay, so let's take a look at that and see what that says. So we'll run the model. Look at the table. And this goes down and it says it triggered 1 at 8:30 on 10/1. And I think 10/4 was the beginning of the weekend. So I'm going to go down to 10/4 and just make sure that at 8:30 on the weekend it did not trigger, and it didn't. Okay, so that seems to be working okay. You can see that during the weekend nothing's happening. Okay, so now it's the combination of these two things that we can use to get our status to work. Okay, so let's now create our status element here, and status. This will now be called off-peak period. And if that's true, then we are currently in the off-peak period. Another thing we could call this is status. It's the current status of it. There are different things we could call this, but anyway, it's in the off-peak. I guess we could also call this in off-peak or something. But let's just go ahead and now trigger the true and the false with those triggers. That's very easy. Just link them. Begin. And I'm just using an event type. See, before I was using onTrue. Now I'm linking it to an onEvent. So all it does is look at that event and causes that to become true at that time. Same thing with the other one. And now, obviously, there are multiple ways of doing this, right? We didn't have to do all this stuff I'm doing. We could have just written expressions, probably, to do this with if statements, but it's just harder to read that. What we have right now, it's pretty easy to follow this logic and to read this once you understand the difference between these kinds of elements. Okay, so we read this or run this, and now let's plot the off-peak status. And now we see that every time that's a number 1, that means true, right? So during October, from midnight until, wait a second. So the simulation started at midnight. That means the initial state of our model of the status actually is in the off-peak. So we need to fix that. And this is something that, it depends on the simulation settings. We could set up some logic to make this be correct right at the beginning. But what I'm going to do for now is just set up the initial condition here to be true. And so, like I said, you could probably have this in expression so that it's smart enough to take the, well, actually with this, yeah, see, initial conditions have to be static. Run properties that are changing through time, such as hour, day, and minute, and those are changing through time, so they're dynamic. But there's the run property called start time. That is actually a static property. So anyway, we could probably write an expression that puts something in here that's smart enough to fix no matter what you set the simulation settings, but let's not worry about that at the moment. So I'm running this again and looking at this, and you see that sure enough it's starting off during in our off peak, and then it switches. Weekends, of course, all weekend we're in our off peak. Okay, so this is taking a bit longer than I expected. We probably won't get as far as I wanted to, but you get the idea. Okay, so now what I want to do is add in my begin the partial peak and begin the peak status, so we can set up the two other status elements. Okay, so let's work on partial peak. I'm just going to copy this and put it right here. So this is begin partial peak. Okay, so if we go back to this spreadsheet, partial peak in the winter is just the other part of the day in the winter. So it's just the whenever it's not off peak, it's partial peak. Well, that's really easy to take care of, right? So that would just be the opposite. So in fact, one thing we could do is we could just say, let me see if we can do this. We could have a status here that if it's not the off peak, then it is the partial peak, at least in the winter. That's one way we could do it. Or we could just have the begin partial always start when the end of the off peak happens in the winter. And let's look at the summer. Summer says 8:30 to 12. Okay, so this is everything but the noon to evening period. Okay, so we'll go back here and we'll say begin peak or begin partial peak. Let's see. So we could say, get rid of that one. Okay. We know that it always ends, or we know that the partial peak for summer and for winter always begins at 8:30 in the morning, regardless of the season. Okay, so we could just put an event here that says when it's the end of the peak, end of off peak, because the off peak ends at 8:30 in the morning. Okay, so regardless of the season, we know that the partial peak begins when the off peak ends. Okay, so I think that would cover us there. Let's see how that goes. And then the next one is end partial peak. Okay. And let's see, that one is going to be, in the winter that was 9:30. In the summer that was, let's see when that was again. So it ends at 9:30. And in the summer it ends at 12. Okay, so we could go in here and say on true, when the hour is equal to 12 and it is the summer, that would trigger the end. Also, add another one, on true. When the hour is equal to 21 and the minute is greater or equal to 30, that ends it. That would do it in both the summer and the winter. 9:30, regardless of the season, it ends. Okay. Partial peak status. All right. Let's see. I'm trying to think if we got the begin partial correct in here. Let's see. If it's the summer, though, it also could start, what time? If it's in the summer, it could start at 18 o'clock, so at 6 o'clock it could start. Okay, so I need to add that in there as well. On true when the hour is greater. And again, I could say equals. I'm saying greater than or equals, but it should be the same. And is the summer. Also, this is only on the weekdays, so, and it is a weekday. So you can see here why it's important to have the terminology the way we do. Because see, now it's really easy to read, right? So if the hour, if it's greater than 6 p.m. And it's the summer and it's a weekday, then that would cause the start. So now we come over here and set up our triggers. So on event, begin, partial peak, end, and partial peak, like that. Okay, and we'll run this and check it. And I'm going to plot this against the off-peak, and you can see that they're oscillating here. This is just the winter time, right? So it looks like that is working okay. Okay, somebody asked, why not use the required precedent? Oh, that's a good point, actually. You're right. I could have done that. I could have gone in here and let's see, not this one. This one right here. Yeah, I guess I could do that. I could say if, well, no, this one's a little bit different because I'm grabbing two different events here. Anyway, there are multiple ways of doing this, but I suppose that we could go in here and say more and check if a required condition is true instead of saying all these ands in there. But I think because we have two triggers, it's a little bit different. In this case, we could do that here. We could say hour equals 8 and minute is greater than 30, and then we could also come down here and say more and then check if it's a weekday, you know, that kind of thing. Those kind of things could work too, definitely. There. Good point. Okay, so last one, the peak. So the peak is, like I said, summer only, and that's here. So noon to 6 is what we want to capture there. I'm just going to copy all three of these, place them here, come down a little bit, and this is the begin of just peak. All right, and let's see, we don't have that. And so this one will happen. This one we could do the other condition here. So we'll go ahead and try that. When the hour is greater than or equal to 12, so right at noon, and then we can come down here and say when, and then check to see if it's summer, right? Is summer. We could say and weekday too. And is weekday. And then that means up here we could do that, something like that maybe. So when it's noon and when this is true down here. Okay, so that's the beginning of the peak and then end of the peak. End of the peak. And then the end of the peak, that one was 6 p.m. Also requires that it's summer and a weekday. So let's remove that one. So 6 p.m., 18, and is summer and is a weekday, like that. I think that's all we need to get our peak status in here, and then we should be well on our way. So just changing these around. Begin peak, end peak, and now we want to see all three of these. together. So I will start up, I'll create a history, and I'll call this the status history, I guess. I'll say peak status. Off, partial, peak. And obviously it's redundant to show all this stuff in here, so we already know it's peak status, right? So I'll just take those off. It's nice that we can have labels now. Okay, so we run that. What do we get? Okay, so we're in the winter, so blue is, you know, we're never hitting the peak. But let's go ahead and run this into the summer as well, just to check. So I'll go up here and I'll change this to run all the way until 10/1/2015, and run it. There's a lot going on, pretty busy. Okay, so we'll zoom into there and take a look here. Okay, so, well, it might be better just to look at a table, perhaps. There's a lot of data. Okay, so we're going down into April. And I can't remember, was it it was the end of April, right? Okay, so here we are, May 4th, and it says here 12 noon, and then that's the peak, right? And the peak ends at 18, that looks right, and right at that moment we start into partial, and then we go to until 9:30 to where we're in the off peak. Okay, so that all seems to be what we want. Now we can set up a selector element that uses the status of these three things to tell us to give us just an integer number that tells us which state we're in. So I'll call this the power category, or I guess power category. No, I don't like that. Peak category. Okay, and we've said here that 0 equals off, 1 equals partial, and 2 equals peak. Okay, and we're going to have, we'll have 3 switches. One thing we could do is we could have, just in case, just for testing, I guess, I'll put a third one in here that's going to be 99, just to show that, you know, make sure we don't have an error here. All right, so when it's off peak status, then it's 0. When it's partial, it's a 1. And when it's peak, it's a 2. So I just want to check to make sure we don't hit any 99s and make sure that those numbers seem appropriate. Just going to zoom in here. Okay, it seems to be what we want. All right. All right, good. So now that we have these categories, now we can calculate the rates as we move through time. So let's start with the easy one, the energy charge. The reason I say this is an easy one is because it's just a rate. We just apply a rate through time. There are no discrete events. But what I want to do though is I want to create a vector of our different use times so that we can categorize, we can move the rates into those different categories to keep track of them. It'll just make the equation a little bit easier. So I'll go up here to Model, Array Labels, and then I'll add a new set here, and I'll call this Use Times. What was I calling it before? Peak times? Okay, peak times. peak times. And we have 3 of them. We're going to have the partial, the peak, and the off, right? Let's see, how did I have the spreadsheet set up? Which one was first? Max, part, okay. The wording, the terminology is a little bit different, right? In the spreadsheet it says max, part, off. That's really, I guess, how we should say it. Instead of just peak, max, peak, partial. In fact, we should just do that, maybe off. I don't want my line styles to change, to vary, so I'll have them all solid lines there. Okay. Okay, so there's our array, just 3 items. And you're probably wondering maybe why I'm creating an array just for 3 items. It's not that big, but what it does is it allows me to write a vector constructor that automatically pushes the values into the right items of my vector. And well, I'll show you what I mean. So what I want to do is create an expression here, and this is looking at the power usage during these different time periods. So I'm going to call this time of use power. So as you recall, we already calculate power in this model. So I'm just going to go ahead and reference the power, and you'll see as I do that, it knows where that is, so it already has the power there. I can run the model and see how much that is using. I'm going to just run this for a month for now. Okay, run that, and just to check the power usage, there's the power usage over time for the month of October. Okay, so we have that, but what I want to do is I want to say how much power is used during off-peak, how much during partial, how much during peak, and put those into those categories. So I'm going to do that with a vector. Vector of peak times, the vector I just created. Okay, so now I can say a vector constructor, and the nice thing about vector constructors is you can reference a thing called row. Row is the current item as it iterates through the vector. This is just like doing a for loop over an array. So if the current row in this vector is equal to our peak category, then look at the power. Otherwise, don't. So what this should do, and notice by default, the time history box is not checked because arrays are by default, they don't store time histories, just to save space if it can. GoldSim's always trying to save memory usage. Okay, so I check that box so I can just check it, so I can look at the power usage. And so remember we're in the winter, and oh, our arrays are 1 based. I forgot about that. Okay, we need to go back to this again. We don't want to use 0. See, arrays in GoldSim are 1 based, right? So the first item in an array is 1, and then 2, and then 3, and so forth. So because I'm using the peak category as my index, I want to change this. This needs to be 1, 2, and 3. And then this down here, same thing, 1, 2, 3, like that. Let's try that again. Zoom in. Okay, it's kind of hard to tell when you're zoomed out, but you can see they're swapping in the winter. So that's good. Let's run this for a bit longer just to check the summer. Okay. Zooming in here. So you can see that the periods are definitely switching through time. But these are now 3 different columns of data, as you can see here. So as I move down through, we'll eventually get to the summer, and you can see we're applying the power usage during each of those categories. Okay, so now that we have those separated into categories, it makes calculating the energy pretty easy. Okay, so one thing I haven't done yet is added the table of energy rates, which I want to do now. So I'm just going to go up a level and put those right here. Save the model. Okay, so let's create a data element that is actually a matrix, and it will be dollars per kilowatt hour, and it's a matrix. Kind of running out of time here, fortunately. Peak times, and then I want to have columns in seasons. We don't have to do this, but it just makes it easy to put this kind of compact data together. Season, and we have summer and winter. Season, okay. All right, 0.16. You know what? I could just copy and paste this. Let's see. No, I can't. It's not in the same. It would be faster just to do this, I guess. 0.09. And there is no peak in the winter, so I just skipped that one. 0.07 and 0.04. Okay, and I'll call this energy rates. And go back in here. And now what we can do is we can apply the energy rate to this power usage. But the first thing I want to do is I want to have I want to calculate the energy rate depending on the season. So I'll use a selector to do that. Energy charge rate, I guess. I should have called the table seasonal energy rate. But anyway. Okay, and now this is a vector because we have the 3 different peak types. But it's not a matrix because I'm switching it on the season here. So what I'll say here is if it's the summer, then we're going to apply, I'm going to grab a column out of that table we just created. So I'm going back to my energy rates table, and I'm going to grab all the rows. So that's a star, comma, summer. And then in the winter, it's the opposite. Winter is the next column. Okay, so that's just grabbing the column, and now that will make it easy to apply those rates to this power in order to calculate the charges through time. And I guess I could call this energy charges, I suppose. And this is going to be a dollars per time. So we could make that whatever time unit we want, dollars per month or dollars per year or whatever. Oh, and this is also still a vector. So we're still just keeping track of the amount that it costs during those peak times. And it's time of use power times the energy charge rate as we move through the season. Okay, and then we could put an integrator there, integrate that through time. Okay, so there's that. And then on the demand, so there are a few more things we need to tidy up there, but on the demand it's going to be a little bit different because we want to take what we're looking at is during those periods, I want to see what the peak is each month. The way that these are meant to be applied, these demand charges, this is the peak during the month that we hit is what we're charged. So if we hit 200 kilowatts, then it's 200 times this number for the month. And since it's a monthly thing, we're going to do a discrete change. And so in this case, what we want to do is first we'll look at also doing a similar thing with a selector here. So we'll come over here and I'll call this demand charge rate. And we also want to have a similar input table like we did before. And this table is going to be dollars per kilowatt. So I'll just put that up here next to this one. So this is dollars per kilowatt. And I think I'm just copying these over, 7.43, 3.98, 0.17. This is 0, so we don't have that charge, 0.52 and 0.12. Okay, so that takes us back to the selector, in which we can do a similar setup as we had in the energy, in which we say if it's summer, then we want to apply the demand, which is dollars per kilowatt. So I'm just going to change this. Demand rates winter, like that. And then the difference here, though, is that we want to know what the max during the period of the month is. Okay, so we're going to create an extrema element here. That's in the functions. And this extrema, we'll call this max during the period. And it's kilowatts. And so now we're getting the max of our time of use power. Oh, by the way, this is also a vector of our peak times. Time of use power. We want to grab the monthly maximums, so I'm going to reset this once a month on changed calendar month. Every time the month changes, it resets. Okay, and then what we're going to do is we're going to get a discrete change. We'll call this the monthly demand charge. And this is just in straight dollars. It's a discrete charge. And there's a charge for each category, but I'm just going to sum them all up. So I'm doing a sum V on a vector, and I'm getting the max during the period. Okay, and then I multiply that times our demand charge rate. Okay, so the rate times the max, that's the amount that I'm going to add. I'm using an add instruction, and I'm going to have this trigger on changed month. You know, it's probably not very good that I have two triggers that are both changing on the month. I should actually create, the best way to do this kind of thing is to have one triggered event that's called something like monthly trigger or something. And the reason for this is because you can control it just in one place instead of all over in lots of different elements. It might seem redundant, but you know, to have an extra element here, but in the end it will pay off, because there could be down the road a time when you want to change this kind of a trigger, and it affects lots of elements. So I'm just going to change this here to be on event my monthly trigger. And obviously, I'd want to organize this model a bit more because I've got things I'm just kind of throwing around. But this is a good idea to, let's see, monthly trigger. So now I can just change it in one place, even though this might affect many triggers. But the key here now is that we use an integrator element that captures those charges, monthly demand charge. Okay, so I have my demand charges here, I have my energy charges here, and now it's just a matter of, oh, and by the way, this is a rate, so I would need to accumulate to compare apples and apples here. The cumulative cost then is going to be captured in my energy charges there. Oh, oops, the sum of my energy charges, sum V, energy charges, like that. The sum of these two integrators is this total, the total energy related costs for this system. And I can use a sum element here. And so maybe you're wondering, well, why use a sum element? You could just add them up in an expression. And the reason is actually just for the visual aspect. So it's very easy for people to see that, okay, I'm adding these two things up. If I just had an expression, just looking at this, you wouldn't necessarily know. So that kind of thing kind of helps. Okay, well, we ran out of time. I appreciate your time spending watching this. I hope it was useful. I know I went through a bunch of things really fast, but the important part here is that we've created logic that can easily be walked through. It's fairly robust. If we change the simulation settings, this all should still work. And I've kept my data kind of separate from this whole model. The only thing that I did not do well is that my hours. What if these periods change, right? What if it's instead of 8:30? What if it's 9:30? Right there, for example. Well, the best way to deal with that is to expose that kind of input data, take it out of these expressions, which I have here, right? So you'd want to maybe make that a little bit more robust there if those were changing. A lot of times they don't ever change. But if they did, then it would be a good idea to expose those and bring those in. So anyway, I hope that was useful. Thanks again for joining us, and I'll go ahead and take questions now. But hopefully we'll see you next time. Thank you.